Okay, good morning. Welcome to the BICSI South Pacific webinar, which obviously we've had to do because of the somewhat odd situation we find ourselves in. First and foremost, before I continue, for those of you that are online, thank you very much for attending. I just want to make sure you can actually hear what I'm saying. You should be able to see a slide that says BICSI South Pacific, and you should have some option there to chat on your screen somewhere if you're on a PC. So if you can find that chat option for me, could you just type something in there? Adam Davis is one of my presenters. He can hear me, but one of the attendees there, let's see what I've got here, Barney or Barry or Ben or something like this. If you can just type something in there to let us know that this thing's working okay, please. I assume that it is. Okay, I don't see any issue with that. That's all right. Yeah, all good. All right, so that's got a bunch of people saying thank you very much for that. I appreciate that. Okay, so yeah, obviously I'm the Queensland coordinator for BICSI, and we've done this session with our two speakers, and we'll reveal who they are if you don't already know it in a moment. And we've also got Paul Stathis on the line, who's going to give you a bit of an update on everything that's happening with BICSI locally and overseas as well. So next slide then, please, Paul. Okay, so obviously some of you guys have found the questions tab. That's fine. If you've got questions throughout any parts of the session, please feel free to drop them in there, and I will answer, or sorry, I'll ask them on your behalf to the speaker at the time. If I get a flurry of questions as they come through, I'll just leave them to the end and cover them at that point. Obviously there is Q&A time allocated anyway, but if it's pertinent to that point, that's not a problem. For those credential holders of you out there, yes, we're going to get CECs allocated for this if you've registered for this webinar, and Paul will cover off what we're doing for webinars in the future as well. Next slide, please, Paul. I think that's it for me, isn't it? Oh no, just this bit. So again, we were trying to follow the format of the original face-to-face type seminar, which is why we've got the two speakers on here. So it is a bit of a long one, so I'll just ask for your full attendance on this, please. And again, if you can keep it interactive with questions, that's great. If you need to step away and come back again, then please do so. But we will be here for the whole time, aimed for about 12:30 start for the second session, and then about 1:15, that's obviously Sydney time, for the Q&A session for both sessions, or whatever's left over at the end. All right, well, that's all there is from me. Just want to welcome you to the webinars. Thank you very much. We have to adapt to the times, don't we? So that's all good. And thank you very much for attending. I will be controlling the session and moving between speakers. But for now, I'm going to hand over to you, Paul, to cover the next bit, please.
Thanks very much, Craig, and thank you, R&M, for facilitating this for us by providing the GoToWebinar platform. We certainly do appreciate that. Very significant issue that we are able to focus on maintaining some element of our normality in spite of coronavirus and all the lockdown. So let me just go through the details here. Pose the question, why webinar, not seminar? Well, unfortunately, just even locally with BICSI South Pacific, it's forced us to suspend 9 of our seminars, plus postpone the New Zealand conference, potentially into Q3 of this year. And if you look at the BICSI website, bicsi.org, we've had to postpone many events. And the concern we have is, how do we maintain the stream of information to people to ensure that, and members in particular, to ensure that they can access information. So as I put there, BICSI has a responsibility to its members to provide education, networking, credentialing. Now we're moving on to the new age of online activity. So I'll very quickly run through what we're doing and some of the rationale behind it. So we're moving into fortnightly webinars starting as of today. We're recording them and making them all available for members to download. So that's members only. That'll be, once you've registered, you'll be able to access the full registration. This becomes important that we can offer it across the South Pacific region to many of our members, particularly credential holders who may or may not be able to attend a live webinar. They'll be able to access that. We're liaising with BICSI credentialing department in the US at the moment to get the CEC process. So we're also expanding to make sure that members are aware of what other members have in regard to online activity to provide education as well as CECs. And of course, we're monitoring the government and health authorities' directives on various restrictions, one of which it says they're deferring the New Zealand conference. So just a quick summary of what we're doing there. Looking at our series of web seminars, today's program, you'll see what we have organised. In 2 weeks' time, it'll be hosted by the West Australian coordinator, Daniel Ellis, and it'll be on Fluke's WebEx platform. We've got a couple of presentations that are focused on fibre. And then Tuesday, the 21st of April, again on Fluke's WebEx platform, will be a single presentation from Murray Teal. There are some big changes happening within ISO and IEEE, particularly on remote powering. We are, unfortunately, as a committee, looking at deferring the release of S009 to specifically deal with remote powering. We will talk about that at another time, but just give you a bit of a heads up about that. And then beyond that, we're looking at multiple seminars. As you can appreciate, with so many speakers that have been put on hold for their presentations, we're going to reach out to them to ask if they can participate in webinars so that we can maintain this. So rather than drowning you in information, we'll put it out every 2 weeks. Any feedback would be most important. And again, if you can't access it on the day, they will be recorded and downloadable from our website. Move on to training. There's a lot of training material that's out at the moment. BICSI has its BICSI Connect Learning Academy, a truckload of documentation there. You'll see the web links for how to get to them. We are exploring a number of options to offer more training through the virtual platform. I've been in communique with BICSI in the US over the last couple of weeks on this issue, just exploring what they're doing. It is interesting that a fairly lengthy process. They're trying to do this on a global basis, so I'm trying to organise material as it comes directly to our members. Just an interesting discussion I've had with CommScope. They've just recently announced that many of their courses will be free to download and participate in over the next 60 days. These are their online courses. And the AV Association of VICSA has also announced that they've waived all online access fees for the next couple of months. So these are good opportunities, and I suspect many other organisations will end up doing the same thing. Quite interestingly, I read just this morning on Statista that some 900 million people are effectively housebound working from home at the moment. This will grow to over 1 billion people. What are we going to do? We need to maintain value to our employers, value to our clients, and also value to ourselves through education. Good opportunity to do that. Just another example, BICSI South Pacific's in discussion with Engineers Education Australia. That's the training component of Engineers Australia. And we're talking to them about delivering online ICT infrastructure courses to not just the IT engineers, but to the wide range of engineering disciplines. And the key focus is the issue of IoT and smart building, smart everything. So they're very eager to get information that they can pass on to their 100,000 members who are of all different disciplines of engineers to give them education. So just a quick snapshot of what we're doing there. The BICSI conference, the New Zealand conference has been deferred. It was scheduled for the 5th of May. It's now been tentatively deferred to the 29th of September. We have a penciled in booking at Ellerslie Event Centre in Auckland. As a result, we're exploring the opportunity, potential for it to become the South Pacific Conference and not holding an Australian conference. We are very conscious that with everyone deferring their events for the first half of the year, the second half of the year will be very crowded, and it'll be demand for people's attention to lots and lots of different conferences will be significant. So currently we're exploring it. If we go ahead with that process, the New Zealand conference may become a 2-day event. It may include the Excellence Awards in it, and we are including a technology experience zone in it, which is a sort of hands-on sort of workshop environment for different forms of technology. So something to look forward to. We'll keep you up to date with all of that. We're also monitoring government authorities on restrictions on timing of our conference, so it might be deferred even more. We don't know. Still things we need to monitor. And I've been in conversation with BICSI head office about a super conference online with many events that have been postponed and cancelled for the next few months. We're contemplating what's actually happening in that space. They're exploring it. They're looking for an appropriate platform to be able to hold thousands of people logging into it. So we'll see how that goes. Don't know if any of you are participating, but Cisco Live has now been postponed to an online event, I think at the beginning of April. They're looking at exploring that as well, so we'll be watching what they do. Should also point out that BICSI at the moment has no plans to cancel its fall conference at the end of September. That's the one in Vegas. So again, just keep your eyes on what's happening with that information, and we'll communicate that as quickly as we get the information. Moving on, some of the big ticket items we're seeing for 2020. Self-isolation, that's the monster in the room. It's intensified. You'll see that NBN have just put out an interesting note that they're trying to bolster the network to deal with the surge in demand, and surge is perhaps an understatement. It is incredible amount of demand for traffic that will be put there. And I think as a result of this, and many of the large organizations are pushing their staff out to their homes to work in an environment where they're not, where they can self-isolate. It will put enormous pressure on B-grade infrastructure. So people's homes will be poor, the infrastructure out there may be poor. So we're going to see the demand for our services for ICT infrastructure professionals to provide remedial support rather than planned networks. So I'm putting it to yourselves as ICT infrastructure professionals that our demand will increase, but the services they require from us might shift from being large-scale infrastructure to solve the problem. And if I can remind you, the key thing we need to focus on is mean time to repair. How quick can we get them up and running? So it's an important component of what we do. And of course, that then leads on to the second component there, availability of ICT infrastructure expertise. We're experts. We need to let people know that we are experts in ICT infrastructure, and we're available to help them to function as close to business as usual as possible, a key component for them. So I'm just rushing through this because I'm conscious of time. My last slide, what to do if you're self-isolated. Use the time to your advantage. Go online, have a look at what BICSI online courses have got, which is an important thing. So I've just jumped to the second one. Again, just a couple of examples. We've got BICSI Connect courses on intelligent buildings in the network, fundamentals in bonding and grounding, areas that many of us think about but don't have expertise. There's an opportunity to grab information on that. Have a look at the CommScope wireless RF and microwave course. Have a look at the BICSI project management for AV course. These courses, the latter two are now being provided for free, so it could be a good opportunity to just access them while they're available. Going up to the first one, the BICSI US conference, the winter conference that happened in early February, which I attended, was superb. There's a lot of really good, meaty technical information. All BICSI members can access that and download all the presentations. Very well worth doing, and I would strongly encourage you to do that. You can download them onto your laptop, PC, have a look at them at your own time. These web seminars are being recorded, so over the course of time, we encourage you to download them, the recorded ones, have a look at them, have a listen to them. If you're a credential holder, make sure you register for CECs, and we'll assist you with that as well. And just one last comment, we're all sick of hearing negative things about coronavirus. Whether it's statements, whether it's social media, say something positive about it. Tell the marketplace that we are experts. Tell them that we understand that there will be problems in self-isolation. Tell them that we'll have greater demand for network infrastructure and that we're there to help. And I think it's a good thing. We need to be demonstrating that we're here to help, that we are compassionate to everyone's problems, and very few people understand the infrastructure side of things. So we come to an important component of being able to save the productivity of companies. So with that, I'll leave it at that, and I'll hand over to Craig.
Awesome, thank you very much, Paul. Yeah, just had a couple of questions there in the background about members receiving emails for different seminars. Absolutely, that is, if you're a BICSI member, you'll be receiving the emails for the future sessions, and obviously there'll be a bit of promotion on LinkedIn as well. And yes, it is being recorded. Just to reiterate what Paul said on that, is that they will be available to members only via the BICSI website if you've got a login. Awesome, so I'm just going to hand over to where are we now? So I'm just getting used to this platform here. I'm getting a hand over to Craig, who's going to be our next presenter. Just find the button for that. It's a wonderful thing of new systems. Okay, so my computer's infected with some sort of virus as well. I'm going to blame Paul for that. There we go, Craig, Clegg, bosh. Okay. Awesome, Craig, you there?
Yeah, I'm here. Can you hear me okay?
Yeah, that's good. Thanks very much. I'll mute myself now.
All right. Good morning all. Craig Clegg here. Hopefully you can hear me. Firstly, thanks to Craig Buckingham and the BICSI team for the invitation. Always good to collaborate and talk about new technology trends. As Paul mentioned, unfortunately not face-to-face today because of coronavirus, but we're doing our best with technology so we can still host the event. Quick background on me. So I currently work for CommScope in the Ruckus division. I've been in IT for about 20 years, 10 years in networking, mainly in wireless. Certainly in 2019 and 2020, we're seeing some major leaps forward with standards, new applications around Internet of Things, Smart City, which I think Adam will touch on later today as well, Smart Campus, new Wi-Fi standards. Obviously, to power all of this, we've got new PoE standards and switching as well. So not a lot of time this morning. We'll move through the slides fairly quickly. Just get the agenda up there. So we'll talk about today 3 key areas or technology trends in 3 key areas. Something I think is important as well is market drivers. We'll have a look at what's driving the market. And then we'll touch on Smart City, converged IoT, which is something that Ruckus is working on. Some new antennas that we're working on as well to provide greater coverage for smart city applications. And then obviously to power all of these new gadgets, we have new PoE standards as well. So these are the 3 key areas we'll talk about today. Obviously, I mentioned IoT, Wi-Fi, and multi-gig and POH switching. Always key, I think, to take a step back and have a look at what's driving the market. So we can see most verticals are still increasing. So we have tablets, smartphones, PCs still increasing steadily. The big increase is Internet of Things. That means a lot of different things to different people. But today, Internet of Things, we're talking about generally low-cost sensors, so lighting systems, door locks, tracking beacons, gas meters, electricity meters. All of those now are being connected online. They're being connected to control them centrally to bring that data back efficiently. And that's causing a huge problem for the market because the sheer increase in number of devices, we have to cable those, we have to bring the data back. It's definitely a problem. A good problem for us being in the data and cabling industry and the wireless industry. But yeah, that's what's driving the market today. Also touch on smart city applications. I think it's key to have a look at some real world examples of where this technology is being applied. And so I think Adam Davis will touch, there's a lot of pitfalls around implementing this as well. So Adam's going to talk about that. But certainly in transportation, we're seeing things like smart parking, which councils like because it raises revenue. Obviously supposed to use or make parking easier for us as well. We're seeing smart street lighting, CCTV cameras or IP cameras. So for instance, if somebody's walking along a path at night, we could turn the lights on, we can face a camera specific direction. With global warming, we're seeing air quality, a lot of environmental or pollution sensors that councils are deploying. Disease control, I think we could probably use a bit of that at the moment as well. But yeah, a whole bunch of different applications. Smart metering is a big one we're seeing with councils. So that's reading gas meters, reading electricity meters remotely. And to power all these applications are different protocols are emerging. So we could see that layer at the bottom. We've got Zigbee, BLE, and LoRa. We'll talk a bit more about that on the next slide. So certainly at the edge, to connect IoT, right at the edge is generally Wi-Fi or wireless based, and then that's backhauled to the switch and the fiber infrastructure from there. But Wi-Fi is just one protocol that's been traditionally used. We're starting to see a number of different protocols emerge. One is called LoRa, which is gaining popularity, and that's really a low energy, wide area protocol. It's designed to go a number of kilometers in distance, but doesn't send a high amount of data. So you can't send pictures or anything with LoRa, but you could turn on a pump, you could measure a gas meter, you could measure a temperature sensor. So like I say, these standards are kind of horses for courses. So each protocol has different advantages and disadvantages. Another popular one, which we're pretty familiar with, is BLE, which is Bluetooth Low Energy. That's being used mainly at the moment for location-based applications. So panic buttons, iBeacons for marketing. So if you walk into the hotel foyer, the application can send you a personalized message. If you walk past the front of the store, BLE can be used to basically track in a near field high accuracy of location. Another popular one is Zigbee, which you may have heard of. That's about the same range as Wi-Fi, but it uses a very low amount of energy. So we're seeing this quite highly used for in-building applications such as lighting systems, door locks, air conditioning control systems, all being connected by Zigbee. And to give you an example, if you tried to connect an electronic door lock with Wi-Fi, the battery might last 3 to 6 months, whereas with Zigbee, you're looking at 3 years, a battery-powered door lock. So again, horses for courses, it depends on the application, but these protocols are emerging, and it's good to be aware that they're not the same as Wi-Fi. There are different protocols, and they have different advantages. Obviously, we still have Wi-Fi, which is very popular for Internet of Things. It's a mature standard, it's reliable, it's fast, and it has a fairly good range. So you will still see a lot of Wi-Fi in Internet of Things. So just what we're seeing as well in the market around these technologies is certainly converging those layers into one layer. So it's far too expensive to go and deploy overlay networks of each standard. So we can't have a Zigbee layer and then another layer for LoRa and then another layer for Wi-Fi. So what we've been doing at Ruckus is trying to combine those layers into the Wi-Fi layer. And we're seeing other vendors do this as well now. So it's certainly a trend in the market. You've got your access point, it's already connected to the switch. It's got good backhaul to the network. So why can't we use that to then backhaul our IoT traffic? So with Ruckus, we have a small USB port where you can insert different radio modules. So we have one that does Zigbee and BLE, and we're looking at launching a LoRaWAN module, and then whatever future standards may arise. Converge that all into one layer. But then there's the question of security. So a lot of IT managers are paranoid about IoT, and rightly so. Generally, these low-cost sensors have not been developed with security in mind, and there have been a number of cases where these sensors have been hacked, and obviously people gain access to the network. So at Ruckus, we've also thought about the security aspect of IoT. So what we do is we actually separate the IoT traffic at the hardware layer, and we securely tunnel that traffic back to a separate place on the network where you can then firewall that IoT traffic and only allow the ports that are required. So the point on this slide, I guess, is if you're looking at this IoT vertical, just make sure that you're looking at security as well, because it can be a problem. I think there was a case where a casino got hacked through a fish tank sensor. So yeah, something to keep in mind. Moving on to wireless now. So we've been working on some better antenna technology to cater for all these devices. We've got Julie Andrews here. She is in an open field with no interference, a single device. The point of this slide is that any wireless vendor can do a good job if there's one device and one access point, but unfortunately in the real world, it doesn't always happen like that. So we've got a very noisy environment, lots of devices talking at the same time, lots of access points talking at the same time, and it's a real challenge for Wi-Fi to overcome this. Understanding why this is a problem, we're looking at co-channel interference, where each access point can talk on a separate channel. The problem is that there are only 24 or 21 channels, depending where you are in the world. And so as soon as you have more APs than that, they start talking over each other and causing interference. So similar to two people on a two-way radio pushing the button down at the same time, you have a collision of traffic. So this slide is probably a bit of an overstatement. I think this is our office in San Jose where we have 874 access points all within range of each other. That's probably not real world, but if you did the scan in any Australian CBD, you would probably see maybe 200 or 300 access points. So it is a serious problem for Wi-Fi. And what's it caused by? Generally omni antennas. So omni antennas, which is just a standard dipole antenna, which is deployed in most access points. It will radiate the energy in a round circle or a donut. And there's not much you can do to direct that signal. So you can make the cell bigger or the cell smaller, but you can't change the direction with an omni antenna. So Ruckus engineers and CommScope engineers have thought long and hard about this. Got a Homer scratching his head. So what is the solution? Essentially, at the end of the day, it is quite a simple solution. So I like to talk about if you're in a noisy pub and you're trying to talk to somebody, what would you do? So you generally move closer to them, you'd listen better, and then you would talk louder as well. So that's essentially what we're doing with our adaptive antennas, is we're sending a stronger signal, but we're also receiving a better signal. And that makes a massive difference to the Wi-Fi performance. So we're thinking about the difference between an omni antenna and an adaptive antenna, which we've been working on, where we can actually direct the signal in a specific direction, similar to a flashlight or a lighthouse. And we can change that signal shape very quickly as well. So here we compare the two access points. We have a standard omni-based access point with 4 dipoles, so that's a 4x4 access point. And then on the right-hand side, we have the Ruckus Beamflex adaptive antenna, where we can, using different filaments on the antenna, we can shape the signal. And this technology has actually been around since the 1970s. We can arrange an in-depth deep dive, if you like, on how it works. But it's been made possible with digital signal processing, or DSP. Back in the 70s, they never had that processing power, but we do now. So we can actually change the direction of that signal up to 4,000 times per second. And that's on a per packet basis per client. So it's a very effective way of controlling the direction of the signal and reducing co-channel interference. Got a quick animation here on how it works. So we have a Ruckus access point at the top, connected to 3 clients at the bottom. It's obviously sending the energy in the direction of those clients. Notice in the room next door, we don't have any energy being sent by the access point. So immediately helping with the co-channel interference problem. If a client moves, the access point will find a new pattern that suits that client, and it will change the antenna. And obviously this is happening thousands of times per second, so the client doesn't notice any difference. If there's interference, the access point automatically detects as well. It can change the antenna pattern again, and it can also change the channel. So it does all that automatically. The IT manager doesn't have to do anything. It's all automated by the access point. What's made Ruckus popular in hotels? is the ability to actually find way around obstacles. So we see a client there's moved behind a metal wall. Obviously, we have to live by the laws of physics as well. We can't try and transmit straight through metal, but the AP will figure out a pattern. If it bounces the signal next to that wall, we can get 1 or 2 bars of signal to that client. So you can see the power of the adaptive antenna and how it reduces co-channel interference, and it also listens and it sends a signal better. And we feel this is critical for the Internet of Things. As client numbers increase and demand grows on the network, we need to start being smarter about how we use the RF. Another thing we do is we account for polarization. So if you remember back to your physics days, if you tip an antenna 90 degrees to another antenna, you can theoretically lose most of your signal. So the antennas we're working on have filaments to account for polarization or tipping the device. And this is key for tablets and smartphones, which obviously get moved around a lot. So you want to account for polarization as well. So that's the plus in our BeamFlex Plus technology. And you don't have to necessarily believe me, but here is a example of a real live survey that's been done in an office building. So we have 4 traditional access points, and we have measured the signal around the building. Obviously, where there's gray areas, we've dropped below the -70 threshold, so the signal is dropping out. And that's obviously not good for performance. So that exact same floor plan with the same survey software, this is with 2 BeamFlex Plus antenna-based access points. We can see a much better signal-to-noise ratio and a much better signal strength in that same space. So I encourage you, don't have to believe me on this the webinar, but if you get some of these APs and test it yourself, you'll see the difference. We often get this question as well, but our typical APs also have beamforming. Yes, they do. So on the 11AC chipset is a technology called transmit beamforming, which was built into the chip. It's not a very effective way. It can shape the signal to an extent, but it's not a very effective way of doing beamforming. So what they're doing there is they firstly disable MIMO, so you lose a lot of performance on your access point. And then they do a phase shifting technique. So they'll shift the phases of the transmission to bend the signal. And it does bend the signal a few dB, but you can see if you bend it in one direction on the diagram at the top, then you open up black spots in another direction. You're also sending energy in directions that you don't necessarily want to. So it's not a very effective way of doing it, but yes, traditional APs do have a form of beamforming, but it's not very effective. The bottom diagram shows how effective the active antenna array is in the Ruckus access points. And again, this is not new technology. It's been around since the 70s, but it's a very effective way of changing the signal pattern. So that's it for wireless. We'll move on to some smart city products that we've been working on. And this is on our access point range, just some interesting things that we've been developing. So obviously smart cities, a big problem is aesthetics. So we have an E510 access point which we've developed. So we've separated the smart antenna from the access point itself. So we can see here on a light pole, just the antenna is visible. The rest of the access point is hidden. And a lot of architects are picking up on this, and designers and town planners, because they like the small form factor of that layout. And obviously it's better for vandalism as well. It's less of a target because it's so small. Smart poles as well, something to think about. So obviously at CommScope, we're venturing into this industry, but I feel it'll be probably one of the most valuable real estate of the future. Well, it's great to have all these ideas about sensors and IoT cameras and smart lighting, but where do you actually mount all that technology? And it ends up being on the light pole. So light poles are becoming very, very popular, and the space on those poles is at a premium. So we're seeing companies develop purpose-built smart poles that basically house all these sensors in an efficient way, so you don't have 20 antennas sticking out the sides. So certainly keep your eye on this smart pole technology. That's going to be a big thing going forward. Another access point we've developed is one that has LTE backhaul. Not necessarily totally new. This AP is, has a dual SIM card, so you can run two service providers off here, or two carriers. But the unique thing is you can manage thousands of these centrally. So we can have them on buses, trams, trains, and you can manage it all centrally from head office. And the LTE can be a backup link, or it can be a primary link. So it can be quite a resilient access point. If connectivity goes down or the uplink goes down, it can still talk back to home via LTE. Another thing to think about is meshing. So a useful feature to have, Ruckus, we've made this really simple. It's one tick box, you just tick it, and the APs will automatically set up a mesh network. And they'll talk to each other wirelessly. So all you have to do is give the access point power, and it will send the data back wirelessly, back to the core of the network. You can't design a whole network with mesh because you lose a lot of performance. So we recommend a maximum of 5 hops, but it is a very useful feature. If there's some place you can't get cabling or fiber temporarily, you can use mesh. It's also good for a backup link. So if your uplink goes down or switch upstream goes down, the AP can talk to its nearest neighbor and keep the network up and running. Point-to-point as well is also a useful tool to have in your back pocket. So although fiber and cabling is not going away, we're seeing more and more of it. Every now and then you do need, or it's very difficult or costly to run fiber. So what point-to-point bridging is the ability to basically have a cable through the air. So we have a home node talking to remote nodes and basically sending the data through the air. Point-to-point's useful as well. So if it's too expensive to connect two buildings, we can have a point-to-point bridge. It's popular as well with police departments and so forth, where they might want to run a camera or high definition camera, but they can't get cabling there, or councils. So point-to-point's being used for IP camera technology as well. And it can be used as a backup link. So if your fiber gets taken out by a bulldozer or something unfortunate happens, you have a backup wireless link to keep your network up and running. Then Wi-Fi 6. So this is a big leap forward in wireless, probably the biggest leap since I've been in the industry. We're seeing a huge increase in data rates, much wider channels. The uplink on the access points going up. So it used to be a gig. Now we're seeing 2.5 and 5 gig. I think some vendors have 10 gig. But yeah, and then again, convergence of this IoT. So we're seeing BLE and Zigbee now built into the board on the access point. So certainly Wi-Fi 6 is the new thing in wireless, but it does come again with some requirements around power. Can't get something for nothing. So we'll look at PoE. We touched on this earlier. So the first use is obviously the new Wi-Fi access points. So traditionally in Power over Ethernet, we've had AF, which was 15 watts. We then saw 30 watts enter the market, so that was AT, and that's kind of mainstream. That's been around for a few years now. But with new access points and new devices requiring more power, we've had new standards come out, which is the BT standard, and that's powering up to 90 watts per port. So a big increase in power as well. Biggest user of this at the moment that I've seen is around cameras. So IP cameras drawing up to 60 watts. So they're pretty advanced cameras with multiple lenses and pan tilt capabilities. But certainly all the Wi-Fi 6 8x8 stream access points are about 35 to 38 watts. So certainly something that you need to keep in mind is this new power standard. And we're seeing lighting systems, LED lighting systems. We're seeing TVs powered off the standard, charging stations, POS systems. So there's a whole bunch of devices that can leverage this higher power. I'll put the slide in there. This is interesting, not necessarily related to PoE, but it is something that we're seeing in the switching market, which is automating VLAN configuration. So if anyone's worked on a switch and you've got a phone that you need to connect or a printer, typically you have to get a technician to go in and change the VLAN on the port so that it puts that device into the right VLAN. We have a technology called Cloud Path where IT managers can pre-program their device classes. So printers, phones, cameras, access points, laptops. And when you plug that device into the switch, it automatically configures the VLAN and the ACL for you on the fly. This is obviously a huge saver in time, and it's also a good security benefit because it stops people from plugging unwanted devices into the switch. So again, just some new technology we're seeing, something to think about. We'll talk about the new Wi-Fi standards quickly. So we've got B, which was 11 megabits, and then we went to A and G. N, which most people, that's when wireless really started to become quite useful. And then we moved to AC, which is the mainstream standard at the moment. And as mentioned, we've just had AX come out. So what the Wi-Fi Alliance has done, and this is fairly useful to remember, they've tried to simplify all these standards so we don't have to remember BG, N, AX, and what they all mean. They've just simplified it. So we've got Wi-Fi 4, which is what N's been renamed to. We've got Wi-Fi 5, which is 11AC, and the latest standard is Wi-Fi 6. So if you see Wi-Fi 6, you know that that's the latest and greatest, and that you'll see that name become the predominant way we refer to AX in the market. Talking about these new standards, traditionally the access point was always a bottleneck. It could never go faster than a gig. So the switch was always king and the wireless was always the slow part of the network. That's now changing with Wi-Fi 6 because the APs can push, 2.5 or theoretically up to 5 gig of backhaul. There's now a potential bottleneck at the edge of the network. And this is where we're seeing a new range of switches being required. So that's multi-gig or multi-rate switches to power these new access points and not be a bottleneck. And that then leads upstream. So good if you're in the switching or the cabling business, we need to account for this increase in data throughput. And with Internet of Things, that's only going to drive even more traffic. So you certainly want to look at your, if you're interested in Wi-Fi 6 and IoT, you want to look at your edge switching, account for some multi-gig ports there, and also your uplink. So you definitely need 10 gig now uplink, and we've got customers deploying 40 and even 100 gig between data centers, for instance, which is good for us if we're in this game. So port speeds, again, we're looking at the different standards. So certainly 11AC, we didn't really see much more than a gig. So that's that cell at the middle at the bottom. Theoretically, we could anticipate 2.5, but we never really saw that in the market. But AX now is tipped it over a gig. So for sure, we're seeing sustained 2.3, 2.4 gig of true throughput on the new APs. So it's certainly time now to have a look at the edge. But we get this question as well, being at CommScope and the BICSI team as well. Obviously, we're looking at cabling and what standards we need to support these higher data rates. So Cat6e, Cat5e is kind of limiting you now. You really want to start looking at Cat6 or Cat6a. So if you want to support 2.5, 5, or even 10 gig over Ethernet, you want to start looking at Cat6a. And generally, the cost difference between this cabling is, and the benefit and speed increase, it's definitely worth considering the later cabling standards. So that's it for me. Trying to stay on time there, had to rush through a bit of it, but hopefully there's a few useful items in there, and I'll hand back to Craig Buckingham.
Awesome. All right. Thank you very much for that, Craig. I do appreciate that. I just saw a separate question there from Adam about switch capacity, in that we're talking about many access points requiring some form of PoE and remote powering, but regards those switches having that capability for all ports to have PoH or PoE++ or levels 2, 3, and 4 and above. Are you seeing much move from the switch manufacturers to make that power available on all ports at the higher levels, or is there typically some sort of ratio?
Yeah, so definitely not on all ports. The power requirements would be massive. So we've got switches that are 1500 watt PoE budget, and that can do PoH on the first 24 ports. Certainly the multi-gig standard, we're seeing that on the first 8 ports or the first 16 ports. I think our most powerful multi-gig switch has 24 ports of multi-gig. So yeah, certainly not the whole switch. And then you've got to think about the UPS, to drive these switches. You've got 1500 watts there. So that also is something to consider. And then for cabling as well, you need to consider heat. So if you're driving 90 watts through an Ethernet cable, and you've got cable bundled into looms, you need to actually, in Queensland as well, start thinking about heat. So there are a few discussions to have around that, but certainly the switches that I've seen are normally the first 8 ports or the first 16, possibly 24 ports.
Okay, thanks. Yeah, and you're right about the cabling side of things. It's something we've spoke about on various webinars, sessions over the past, is there's a kind of somewhat of a misconception or ignorance, I suppose, in that, they've got some cable in the wall already. Let's go out and spend X amount of thousands on upgrading the wireless infrastructure without doing anything on the cable side, only to find that it, not necessarily can't deliver the remote powering, but couldn't necessarily step up to the 2.5 or the 5 gig that the new switches require. So a whole lot more consideration there, I think.
Yeah, for sure. So I've been talking to some engineers, and yeah, if you're running 10-year-old Cat5e and you're thinking about running 60 watts over that, you've had rats and things chewing on the cable over the years. Yeah, you probably want to think about running some fresh Cat6a or to support those multi-gig standards as well.
All right, Craig, thank you very much. Just before I sign you over to Adam, there was an analogy you made in your presentation that made me, at least, a little bit sad. And it was when you were talking about adaptive antennas, and think about when you're in a noisy pub, and it was at that point I got a bit sad considering the current situation, because we ain't going to visit that for a while, right?
Yeah, it is a bit sad. I saw in the UK the pubs were full and they had to shut them down. But yeah, it is a bit sad.
All right. Well, look, thank you very much. If you've got any other questions for Craig, please feel free to drop them into the questions panel, and we'll answer them at the end. But for now, thank you very much, Craig. I'm going to hand over to Adam now. So just give me 1 sec. There seems to be a slight delay on this. There we go. Use that one. Okay, over to you, Adam.
Excellent. Thanks, Craig. Why am I showing that? There we go. All right. Can you see that okay, Craig?
Yes, I can, mate. Thank you.
Yeah, excellent. All right. Morning, everyone. Yeah, thanks to BICSI and the team there for the invite to come and have a chat virtually with everyone. It's a little bit odd sitting in your home office with no one in front of you doing this, but we'll battle on through. For those who don't know me, I'm the owner and director of TPL Connect, also managing director of EdgeDC. I'm a consultant in the wired and wireless infrastructure space and technology space. Some things about me, housekeeping. I'm not the technical guru. Certainly have people that are. I may say a lot, and if you can't tell, I do have a monotone voice, so I'll try to keep it as upbeat to stop people from falling asleep in their home offices. And for those people playing wank word bingo at home, grab your pens because there's going to be a few as soon as we start talking about smart cities. So some of the relevant projects that we've worked on there, just with Sunshine Coast Council, Townsville, and a few others, Telstra, and doing a lot of in the IoT readiness space at the moment around audits and current state. But let's get the elephant out of the room. Everyone's sick of hearing the word smart city. It's definitely the most overused term in the industry at the moment. I've seen some new terms coming, intelligent and alike, for naming these sorts of environments. So hopefully some other ones will catch on pretty soon. But there are some real connections between smart cities, IoT, and our ICT sector. First is due to the fact that the growth in smart cities and the amount of connected devices, that just there's going to be an exponential curve on data creation, and we're already really seeing that. And it's been driven by machine-to-machine devices, especially in the coming years as we deploy more and more of these. So the need to capture, analyze, and store this data is now becoming absolutely critical. And although the data rates and packets are quite small, as Craig pointed out there before, their sheer quantity means that we're on the crest of another wave of data creation. So the importance of the transport layer around infrastructure is now more vital than ever before. So if we're talking about smart cities, does it mean that we were done before? Well, the short answer is no. But Gartner predict that this year, 50% of all smart city objectives will be based on climate change, resilience, and sustainability. That was before we had a certain pandemic change a lot of people's focuses. And what this means is we're looking to technology just to make smarter decisions. In particular, we're using the data that technology can now deliver to make better decisions around things like bin collections with sensors and things like that. So the World Bank predicts that landfill will be a $375 billion strain by 2025, just as an example of where they're looking to use data. So the current state, as I see it, is that the hyperscale is leveling out. We're seeing that a lot of the early adopters and the ill-informed may have been caught up and suffered with vendors that may have had their own vested interest in mind, especially around data retention. But what should be happening is the ability for the industry, businesses and regions to be able to innovate and optimize using this information. In particular, our councils should be able to make better services for the constituents. This is through better things like transport, waste, and most other functions through empowered decision-making from the analytics. So if we look at the hype versus reality, speaking of Gartner, who doesn't love a Gartner hype cycle chart? So what you'll see here is the adoption versus the hype. So what we're seeing now is that we're moving into that, moving out of the trough of disillusionment and into a slope of enlightenment where people are actually realistically deploying projects, meaningful projects. Hence what I said before there, we're getting a lot of OT audit work at the moment in readiness for a lot of IoT deployments. And it's quite an interesting space when you get out of the ICT world and into the OT world and start looking at how they manage their networks, or in some cases do not manage their networks, and the amount of interesting things you find on facilities managers' desks, like 4G routers that are plugged into BMS networks and the like. So where are we now? Well, I suppose the real reason is why we're doing this. What's this hype around smart cities and IoT? Realistically, it's to automate and enhance. Benefits can include the removal of human error and optimization of processes. One of the big things here is to not forget the fact that we are trying to replace people here. So yes, there's some massive concern around this. Jobs will be lost, and the skill sets that are required to do this type of work aren't the skill sets that are going to be found in the people that are probably going to be losing their jobs. So it's an interesting conundrum for the industry as we move forward. And you do see a lot of technology futurists and evangelists just saying hell bent on replacing every level of human interaction. We're even looking at doctors and scientists and researchers now being replaced, if not fully, in part. The interesting part from my perspective will be, our reliance on robotics and the like, and are we dumbing ourselves down? If it's enough of my fear mongering. Let's talk about the human factor. So if we talk about technology and smart cities and IoT and what that really needs to look like, it's the user experience and the interaction with the technology that's the key factor. To note an interesting point, I think, in my opinion, I think technology succeeded if you don't realize that you're interacting with it. A good example might be in aged care facilities where we're using technology to create a safer environment for aged care patients. Things like form monitors, wayfinding, RTLS, and the analytic platforms analyzing behavioral patterns. These should be technologies that are oblivious to the user, but enhance and save lives. So with all that smart talk, what does it actually mean? Well, at the moment, excuse me, currently there's around 500 cities with a population of 1 million people or more. China alone has 221 cities with 1 million people, or will do by 2025. So the ability to make informed decisions on infrastructure planning, transport, and other major utilities is absolutely vital. That's where smart technology is coming in, and that's what it's all about. According to Frost and Sullivan, to be a smart city, you actually have to have a number of components. You have to have 5 of these following ones. There's smart energy, healthcare, buildings, mobility, infrastructure, technology, governance, education, and would you believe the 9th one is actually smart citizens. So I'm not entirely sure how they measure that, but anyway, that is part of it. So the world's expected to have around 26 official smart cities by 2025. The current number is just creeping up towards 10. The most important consideration for these now with smart cities is IoT and the edge. To do that, we need ubiquitous connectivity, and that's a bit of a challenge, obviously, in countries like ours. Just ask the NBN. So speaking of connectivity, what does smart city connectivity look like? Well, as Craig pointed out in his presentation, there's a number of different connectivity requirements around traffic, Internet of Things, smart parking, water, metering, waste management. There's a plethora of different options here, but every part of the city needs to communicate. Nearly all of it will live on a network, and some of them are quite bandwidth hungry, CCTV, video analytics. Others are highly latency dependent. Others are remote and difficult to maintain. So they all need a foundation transport layer to support data sharing. So now more than ever, the importance of fiber and wireless is exponentially growing as we look to deploy these projects. So what does that look like? Well, if we look at a foundation layer approach, this highly complex graph that we put together sort of looks at that and how we build from the in-ground asset up through the differing layers to get to that data processing layer. And what it's meant to show is the importance of the foundation layer. So the focus today is what we're interested on. It's the relationship of the foundation layer with the whole ecosystem. Anyone playing bingo? There's another one for you. From my discussions, no matter what we decide to do, nothing will work well without the transport layer. So whether that be wired or wireless, as a hypothetical, if we have no fiber optics, that's going to mean no CCTV. If we have no LTE, that's probably going to mean no sensors. We are looking at things like LoRaWAN, but LTE, especially with 5G coming, is going to be heavily relied on. No local compute means no real-time data, so talking about the edge again. And where does the compute happen? Well, normally in a data center, and that's where the change is coming now as we push further and further out into the edge. These IoT networks are distributed, and DCs and connectivities are not. So we will see a real need and growth in edge data centers regionally. Everyone's talking about it, but the economy of scale is really difficult to put together in these small scale data centers. Netflix has been successful with a company called Edge Connects in the States, deploying these POPs or nodes into regional areas, but their scale that they consider edge is obviously a lot greater than Australia. So let's look at the major influences on the foundation layer now. So this graph just represents the take up in connected devices. So right now there's nearly 25 billion wirelessly connected devices, and that's going to continue to grow past 30 billion, as Craig showed in his presentation there. But the expectation is also for faster connectivity. The growth of machine-to-machine devices is absolutely the key driver of this. So believe it, the machines are talking to each other, so be scared. You can see there in that graph, the orange represents the machine-to-machine take up. Most of the other growth areas like mobile handsets has been pretty steady increase, local network infrastructure again, and tablets, but the high growth area is machine-to-machine. And to enable all these types of devices to seamlessly connect, there has to be a myriad of technologies for transmission. So again, as Craig discussed here very well in the last presentation around wireless, we're seeing 802.11ac and AX becoming prevalent. There's a plethora of different options out there in wireless connectivity as well. Do need to update that slide. As we push to 4G, as we push to 5G, 5G is going to be a big component of any smart city or IoT deployment in the future. One common theme though is they all use wide backbones, and at some point more than ever, they're using fiber optics. So this represents the interconnect between differing wireless and RF technologies. IoT and mobile devices are driving the need for these improved wireless connectivity, which in turn drives the need for a resilient wide backbone. You know, we've seen projects where the core count for a backbone in regional areas is greater than what the telcos are installing. You only have to look at the Gold Coast that recently installed an 844 fiber, I think it was, as part of their council-owned network. The distributed network is the biggest concern for latency-dependent devices. So there's been tests on fibers linking Brisbane to Sydney, and you know, we're talking as long as 36 milliseconds potentially, which is over a half a second in real-time delay analysis. So if we're looking for these types of networks to drive things like autonomous vehicles, that decision-making process of a half a second or more is just way too long. So we need to be looking at other technologies. So with the massive take-up of wireless, there's new standards coming to cope with the very high throughput Wi-Fi. So we're looking at speeds of over 1.3 gigabits and a minimum requirement of Cat6a definitely being required for structured cabling. Minimum 10 gigabit capable balanced twisted pair to support these PoE++ and PoH requirements. As of now, we have higher bandwidth Wave 6 products coming into the market, most of which are point-to-point and not mesh or point-to-multipoint. A requirement around solid core conductors is advised for the channel to avoid heat buildup and associated cable bundles running these new types of PoE. And to support the moves for wireless optimization, we're looking at grid-based designed architectures, mutos to support rapid deployments, fast configuration post-install, and it allows redundancy and future-proofing in the network. Remote AP locations may require new technologies such as powered fiber, which is basically a fiber optic cable with a built-in copper conductor to allow power up to about 600 meters, which is a pretty cool product as well. And one of the big use cases for those is smart poles. As Craig discussed earlier, you know, there's multiple uses for these, and we're seeing a really fast take up for smart poles in especially new developments. Councils are looking towards these types of deployments to support smart lights, CCTV, IoT gateways, sensors, and of course the Wi-Fi, plus public address and safety concerns as well is another big driver. So duress buttons, which people love to press, not realizing they're on camera, but it is a real concern. We've had some major issues on the Sunshine Coast with that. So with so many devices and equipment being connected, you know, how do they integrate? Many projects are now looking at things like manager of managers or middleware products to dashboard all of these different disparate technologies and systems that we're looking to deploy. And they're stretching the existing IT and OT streams. So to be successful, I think a smart city plan needs to engage all stakeholders. The network stretches well beyond the standard architecture that we're used to in IT now, and the management of that is becoming highly difficult. A matrix mapping out the integration requirements is a must, and it's a massive undertaking. The amount of different protocols and interconnections on these networks is absolutely huge. Consideration of differing protocols and interconnection capability is also a massive task. The supporting foundation layer needs to be designed to be able to support this integrated and converged architecture that we're now looking at. So designing to consider all of these is very difficult. There's really no clear technology roadmap. These technologies are all new and we're all learning as we go, but they have to be able to support remote devices, and that's becoming even harder. So ensure you have an integration plan if you're looking at these types of projects, and look at converged network designs, as Craig discussed earlier, because we are looking, of course, towards the edge. So the edge mainly consists of three sectors. So it's devices and appliances, sensors and actuators, and gateways and aggregation. Sensors will rule the edge of the compute environment. The issue is the upkeep of these though. So there's the installation, the commissioning, calibration and testing, firmware updates, and the little chestnut of battery life. Then there's the audits and of course security, resets and removal. And then while we're all talking about this, the connectivity to support them. So overseas, there's trials on energy meters connected through home area networks that they're deploying. These are connected to a larger sensor network that the energy provider actually manages and utilizes to redistribute power. This allows for smarter choices with power usage and distribution, plus all of the smart home devices that we're connecting up now. And what effect will this have on our edge devices? Latency is obviously one of the major design considerations of most IoT device networks. So how quickly do we need to be able to process the data is a big consideration in what we're looking at. Currently, the majority of IoT devices rely on cellular networks, which at the moment, are high usage and it's not ideal for low latency or efficiency. Requires devices to have more regular heartbeats or communications back than what are ideal as well. So another medium or transport of communication is required. So people are looking at LoRaWAN, Sigfox are also gaining ground, but 5G is a real game changer here. Another consideration in edge is edge compute. The need for gateways that aggregate real-time data for these sensors. They perform local analytics and are based on the results that they're performing. They take localized action to prevent possible faults from further propagating into the networks. Excuse me. The need is a communications infrastructure to connect these gateways to server clouds. This will drive the requirement for edge micro data centers. So with all that data being created and analyzed, what role does it actually play? A huge role. Obviously, this points out that how Gartner see the data ownership being managed and access to the data and predictions around what those end devices will look like. So if data is the answer, what data are we actually talking about here? Well, to be honest, it's different for each instance. This is where it can get tricky. Let's say it's an agribusiness that is your core regional foundation export. So you might be looking at things like transportation of the product being an issue. The weather in the region could be severe and a better predictive analysis would help. Is it that the farmers need better connectivity to transact at a local level? Are there flash floods? Would remote sensors offering early warning systems be a great project? Then there's the cracker of the data ownership. Lots of councils are scared of owning the data, somewhat rightfully so due to probity and privacy. However, some of the smart cookies took advantage of that fear early on. So councils were deploying things like wireless networks, and now they don't own the data and they have to pay to get their own data back. Not that our large telcos would do such a thing, but that's becoming an issue for them as well. So if we talk about data, we need to talk about privacy. Many people don't realize it though, that they are often just a MAC address. So the fear around personal data being shared is mostly not true. But the fear comes from perception, right? So wireless connection and heat mapping won't reveal what you like to watch on YouTube or really any other personal data. It does, however, potentially create a very realistic avatar of you. We've seen data collection spreadsheets from the likes of Telstra, and they do actually have columns in there for names, but it's always blank. So the idea behind gathering all this data is to access it so you can analyze it. If you can analyze it, you can inform, and if you can inform, you can improve. So you can improve process, efficiency, and way of life. And if Gartner are right, we do have 30 billion IoT endpoints in the next few years. Do we want to talk about network security? Because that's going to be massive, as Craig touched on, and these devices inherently don't have great security. So I think I'll leave that topic alone because it's a massive topic unto itself. But just how much data are we actually talking about here? If we consider like 30 billion endpoints and what that will mean from a network and infrastructure perspective, it's enormous. This is like the Internet 2.0, and it's going to create exponentially more data. We're doubling the amount of data every 2 years that were created in many different ways, and IoT is a big part of that. To give you an idea of data creation that's a little bit left of field, the new Super Hornets that the Defense Department are using, it takes 2 weeks to analyze the data from one flight for those guys. So it's just everywhere is creating massive data, and it's from the sensors that are being deployed on planes and in councils. And on a larger scale, modern autonomous vehicles, they create 80 megabits of data a second, even though 3% of Australians don't believe they exist, and 78% say they'll never trust them. So on trust and beliefs, what are the issues that we can foresee happening here? This is an area that is now seeing help from state and federal level, getting funding. So there is real projects, but still most projects are council funded, and most councils are really not cashed up. So they struggle with the pitch and the problem. They need to spend $20 million to save $50 million is usually how you try and position these projects. Start small is probably my advice. Too many projects aim too high and fail. We've seen a number of those, and it can be a costly mistake. One of the biggest issues facing councils is they're simply not equipped to deliver these types of technology projects as well. So the ability to undertake an impact assessment and ensure the integration is just too large for councils to manage and skill up for these types of projects. So we're seeing poor execution in some of these, and it's really making the end product suffer. So poor information is being given to the client quite often. There's a poor understanding or little to no stakeholder engagement, which is vitally important in these types of projects. And then we look to ownership. So often IT are not involved in the technology decisions because it's been driven out of an OT sector. IoT and smart technologies have many more stakeholders than what we're used to. Ownership and maintenance needs to be discussed early on in the piece and agreed to. It's an important part of the process. So to outline the problem, this table shows the standard IT understanding of its ICT environment compared with an IoT environment that we'll see in smart cities. So what we're trying to outline there is at a user level. In the IT world, it's normally a human interacting. In the IoT world, we're talking about a machine interaction. The architecture is dynamic. Flexibility, it's mostly static. Understanding-wise, we are still learning. Ownership is still a point of contention and discussion. And security is a vital consideration and something that's unknown, a point of contention here. We are seeing, most of these sort of network hacks are coming in through an IoT or OT level now. The security architecture, it's relatively unknown as well, which is kind of scary. I honestly wish I knew a lot more about cybersecurity because it's a growing spot and something that I think will only continue to grow over the next few years. And there will be more to come here, I think. So what options do we have? Well, there's a market here for many different options, but unfortunately, as a service is perfectly aligned to Smart City Factor, and that's due to many considerations, but the main one being that very few, if any, councils or regions or governments really are funded for these. So to deliver the technology projects, they are planning different procurement options. So the ability to deploy these projects for little upfront cost and the possibility of an evergreen product is very attractive to these clients. The as a service model also helps drive the need for local compute, as many vendors are offshore, hence needing local cloud capability for latency dependent devices and software. So really it's a win-win for everyone. The vendor gets ongoing revenue here. Users get an evergreen product without the upfront costs. Together they can go on an evolutionary journey too to improve the product, both for the user and the vendor, because these products are so new. But how do we know that we're using the right technologies? Ensure that you have a policy to include and be based on data governance while showing the goal of using the data would be my suggestion. Have a guiding set of principles. They guide every smart city or IoT decision that you should undertake. It acts like a coarse filter. There's usually 8 or 12 of these, or up to 15 that are created by the client stakeholder team with input from outside consultants. It then becomes like a first gate in an evaluation for any supplier, technology, partner, within the ecosystem that they're looking to deploy. If any of these principles aren't met by a supplier, it shouldn't be considered. It's a first level filter. Then have an architecture for the technologies that are being considered. The integration into IT, OT, and the business, and don't do technology for technology's sake. If clients are looking at smart city projects, it might be a good guide to look at what the mayor was voted in on, their top 10 promises, and look at IoT platforms that may be able to help enable those. So what does the future hold? Seriously, I'm not sure where this is all going, and will we have self-driving cars in the next 5 years? Will we have no low-level decision-making by humans? Will Skynet become self-aware and wipe us out anyway if coronavirus doesn't? We could talk about behavioral analytics, self-learning video analytics, smart infrastructure, energy management transformation, smart homes. However, all I know is that there's many exciting technologies that can seriously enhance our lives as human beings. The data being generated will drive the connectivity and data center growth like we've never seen before. But I hope we can find a balance of having the right amount of intrusive and non-intrusive factors that enhances all of these, but our working and business prospects as well as that. The fundamental criteria of ensuring it enhances and integrates into our lives is vitally important. And of course, the growing demand for wide and wireless networks, it's going to be exponential in the coming years. Shields predicts that the sensor market will be over $5 trillion over the next 5 years. The need for more connectivity and edge compute has only really just begun. We really haven't seen any edge compute being deployed at scale. There's a lot of marketing around it, but not a lot of actual action. The need for more and more foundation layer infrastructure will continue. So stay ahead of the transition to smart by taking a foundation layer approach. Everything is built off what we do as an industry. Work with all streams of business during the evaluation, have a plan. There will be lessons along the way, not all of them painless, but I do think in general, the smart city revolution will benefit all of us in the long run. So thanks for listening to my rant, everyone. And of course, these are only my thoughts and opinions, but I'd love to hear yours. But I also do believe that we are really on the crest of a huge infrastructure deployment to support all of these pretty cool technologies. Thanks, Craig.
Awesome. All right. Thank you very much for that, Adam. Yeah, some great oversights there of what's happening in that space. And obviously, it's an area that you are very passionate about and something you know a great deal more than the rest of us, that's for sure.
Yeah, so look, thank you.
Well, you did a good job of making it look like you do, mate. That's for sure. But it does highlight an important issue, right? Is the infrastructure in smart cities and everything else is the building block of everything that we come to rely upon. I mean, we couldn't be in a more pertinent situation now of having to rely on some form of infrastructure right now just to even do this webinar. But like you say, as things ramp up and things get more intelligent, that infrastructure is going to have to be better thought out and much, much better than what it currently is. So thank you very much for that oversight. I do appreciate that. Just a couple of points. Just to wrap the seminar up, and thank you. First of all, if you are a credential holder on the call, so we will have a full list of attendance from everybody that's logged in and stayed logged in throughout the session. So I'm glad to say it's been nearly about 100% of people that logged in have stayed on, which is great. But if I could ask the credential holders to email BICSI South Pacific or myself or both, just because I don't know everybody who is a credential holder, just to tell us who needs their CEC, so we can just update the spreadsheet of the attendees from today. On the RCDD side of things, a very odd one, but I don't think there's a better place for it, honestly. Baz Hughes has highlighted that the Department of Transport and Main Roads is looking for another RCDD to start as soon as possible in Brisbane. So if you're an RCDD Brisbane based and you're looking to get stuck into what they're doing, please feel free to contact Baz Hughes. If you don't have his contact details, give me a shout and I'll pass your details on. So I'm just reading a text message from Paul. That's all right, yeah. So again, this session will not be available online via the current medium after today. It will be moved across to the BICSI website. So if you know people that missed it today, if they're not BICSI members, they won't be able to access it. But if they are, they'll be able to log into the BICSI website and view it from there and still get their CECs, which is an important point. So thank you very much for me as a BICSI coordinator. Obviously, we've chucked this up on the R&M GoToWebinar platform this time. It's Fluke's turn for the next couple, I think. But I hope to see you all and speak to you all via this means very soon, and all things being good, face-to-face in the near future. So that's it, just to wrap up today's session. Thanks very much again to both of our speakers. Again, if you've got any questions after the day, please let me know and I'll pass them on. Awesome. Thanks very much, everyone. Enjoy the rest of your day. Bye now.